Hello everyone. Today we're going to be talking about the JavaScript reduce method, which is available on JavaScript arrays. The JavaScript reduce method takes in two values. The first value is the arrays that you call it on, and the second value is called an accumulator. And this accumulator could be a number or an array or anything that you can dream of. And it produces an output of another value. So let's see the example we have here. We have a set of an array of numbers, and this array of numbers contains 4 numbers. And we want to multiply each number by 2 and produce another array, which is the arrays that you see here in the commented output, which is 2, 6, 20, and 16. So how can we go from the initial state to the final state? There is a straightforward way, which is to use a map or a for loop and generate this final array. But using a functional approach, like a functional JavaScript approach, we can make use of reduce to generate this. So let's see how we can do this. So the first thing you need to know about reduce is that it is an immutable method. So that means that it generates a new array as an output. It doesn't mutate the actual numbers array or the original array. So we're going to create a new variable for the array. Let's call it output for consistency. We will assign it to the reduce function. So we will call the reduce function on the numbers array, and we will, and we will pass it the initial value, which is the function that will do the reduction. So we will pass it the reducer, and I'm going to write this function in a minute. And the second parameter we pass it, or the second argument, is the initial value for the accumulator. And this is an optional thing. So you can enter this value or you can ignore it, and it will treat the first element in the array as the initial value for the accumulator. But in our case here, we want to return an array. So the accumulator should be initialized as an empty array because we're going to be adding items to this array. Right now, I'm going to write the reducer function. This reducer function takes in 2 values. So the first value it takes is the accumulator, and the second value is the current value. And it returns a third value, which will be assigned to the accumulator on the next iteration. So what we want to do here is that we want to multiply each element of this array by 2. Then we want to return it in an array, and we want to add it to the previous array that the accumulator had. So in order to do this, we can't use push because as I mentioned, the reduce method is immutable. So it will not allow you to use push on the accumulator. Instead, you can use the ES6 syntax for spread operator. So you can return an empty array and spread the accumulator in it. Then you can apply the operations, the multiplication operations that you want to do on the current value. So you can say something like current multiplied by 2, and this is going to be the returned value from the reducer. And just to test this out and make sure that it works, I'm going to log this. I'm using an extension called Turbo console log to create these log messages if you're interested to know what that is. And I'm going to run this. So as you can see here, it generated the expected outputs that I wanted to have. And right now, I'm going to walk you through this process and show you how this happened and what happened exactly inside this reducer function. So the reducer function is basically a JavaScript reducer, which is similar to the reducers that we have in Redux, for example, where you initialize it with an initial state or previous state, and you give it an action, and it returns a new piece of state that then Redux merges with the existing state. So right now you are passing it an accumulator, which we initialized here as an empty array, which is the initial state for it. So in the first iteration, the accumulator is going to be an empty array, and the current value will be assigned to the first value here in the array, which is 1. And the output of this step will be an array of 2, because you multiply the 1 by 2 and you return 2. So this is the new accumulator. So this is the new value for the accumulator. And on the second iteration, the accumulator is initialized by 2 because this is the values that we got from the last step. And the current is assigned to 3, and the accumulator in this case gets a value of 3 by 2, and we're gonna spread the accumulator, so we will have 2 here, and we're gonna add to it the value of the current multiplied by 2, which is 6. And the operation goes on until we have a final accumulator of 2, 6, 20, and 16, which is the final value that we reached here. And I guess this completes the examples that we had here. And I just want to go quickly through it and talk to you more about why we should use a reducer instead of doing a loop. Like maybe you would say that a loop is much easier because it's easy to debug things inside the loop. Like you can have console logs inside the loop and make sure that everything works properly. But here you can't have this sort of console logs because the reduce function is sort of a black box for you if you don't know how it works. But the point here is that as long as you understand how reduce works, you don't need to have it's much better for you to write to use it instead of using a loop, because this allows you to have something like a reducer here where you can write unit tests to test this reducer individually without having to use console logs or anything like that. So you can take this reducer out and test it individually. And it's also better for the performance because this is an immutable approach where you generate a new reducer array. So it's much better in terms of performance and in terms of readability here. And that's it today. See you in the next tutorial. Bye everyone.